So as I was saying, a solution, it is a mixture that is made when you combine solute with a solvent. Okay? So you can also write solution like that. It's the right way to write it in chemistry. Okay? That's how you write it. Now, uh, let's work in the part A. Let's work in the part A. It says that is 4.5 m solution, okay, of H2SO4 sulfuric acid in 1 kilogram of water. Okay, so from this we need to gather information. We need to list the givens. That is going to be the first step. Okay, now what do we have for this problem? Take a look. They are giving us 4.5 m. 4.5 m tells you about concentration. Okay, so this is actually the concentration of the solution, because we have lowercase m means that this concentration is measured in molal. Okay, so the molar concentration for this solution is 4.5 m. They are giving us 1 kilogram of water. Okay, that is the other part of the givens. So the solute and the solvent. What is the solute in this exercise? What is the solute in this exercise?
The solvent is the 1 kilo water.
Okay, the solvent is water. Therefore, the solute will be the sulfuric acid. Okay, so the solute is H2SO4 and the solvent is water. And according to the formula, what do we need for molar concentration? According to the formula, okay, so according to the formula for molar concentration, we have an equation that says molar concentration is equal to number of moles of solute this is divided by kilograms of solvent. So the first step that I always recommend to do is to identify which one is the solute and which one is the solvent. We already did right here, okay? We already know that solute is H2SO4, sulfuric acid, and the solvent is water. That is important. That's why I do it as a step 0, always. Now, what do we need to get? According to the problem, it says determine the number of grams of solute. Okay, so I need to know my solute. So I need to know the grams, the mass in grams of H2SO4. This is my unknown. Okay, this is my unknown, and this is what I'm going to focus on. So let's see. The problem also gives us the molar concentration, but also the mass of water. The mass of water will be the mass of my solvent, because the solvent in this of the problem is just the water, okay? So for the solvent, that is water, I have the mass in kilograms already. That is 1 kilogram. That is also part of the givens. Now I'm just going to focus on the solution process. According to the solution process, I need to find the number of moles of solute, which means that I need to do an isolation, okay? This isolation is very simple. The kilograms of solvent are the denominator, okay? It means that they are performing a division. So they are dividing, but when you move it to the other side of the equation, they will be doing a multiplication. So in the end, the isolation for number of moles of solute will be molar concentration times kilograms of solvent is equal to the number of moles of solute. Okay? Now, with this, you can just arrange again the equation. If you're just like me, you would arrange the equation in this way, because I like to put my unknown in the left. I just arrange the equation in the other way, just to have my unknown in the left. Okay? I just write it again. I just change the position. I didn't do anything else. So right now, all I do is substituting the givens. I have my molar concentration, that is 4.5 m, and I have the kilograms of solvent, water, that is 1 kilogram. So, according to this, my number of moles of solute, the solute, that is H2SO4, is equal to 4.5 moles. And with this, you finish the first part of the problem. Now, what comes next? Remember, the problem is not asking you number of moles, it's asking you number of grams of solute. So that means that in the end, you have to get from the number of moles, you will need to get grams. And what is the conversion factor that we use to convert from moles to grams?
The molar mass.
Exactly, the molar mass. Now, here we're going to be using the molar mass of, remember that we are looking for the solid. So we're going to be using the molar mass of the solid. So, in the other part of the process, this is going to be my step 1. Okay? That is using the molar concentration equation. And in the second part will be the conversion from moles to grams. As you said, we will be using the molar mass of the solid. So that will be my other step, getting the molar mass of the solute. So my solute is H2SO4. So we need to get the molar mass. The molar mass of H2SO4 will be 2 hydrogens invisible 1 sulfur, 4 oxygens. And you replace the elements by the atomic mass from your periodic table. I use the rounding, you know it, okay? I use the rounding numbers. So, for hydrogen, I replace hydrogen by 1 gram. I replace sulfur by 32 grams because I rounded, okay? It's okay. It's okay to round. And I replace oxygen by the atomic mass, which is around 16 grams. So this gives me 2 grams, 32 grams, 64 grams. How much I have in total?
98 grams mole.
98 grams per mole. Remember that this is a fraction, okay? This is a fraction that you can write as there are 98 grams of H2SO4 in 1 mole of H2SO4. It is the same, okay? But we write it like this because it's easier, okay? Now, that is what it represents. It is 98 over 1 mole. Always over 1 mole. So, after this, you perform the conversion process from the moles of solute to the grams of solute. So the moles of solute is the amount of moles that we got in the step before. These are the number of moles. Okay? So we say 4.5 moles of sulfuric acid, and now we multiply times my molar mass as a conversion factor. In what position I have to write the number of moles? Up or down?
Down.
The moles are
The
going to
moles,
be down.
the moles are going to be down. So here you're going to write 1 mole of the substance that is sulfuric acid, and in the top you will be writing the number of grams, 98 grams of the same substance, sulfuric acid. This allows you to cancel moles with moles, and then you multiply and you get how much?
441 grams.
441 grams of the solute that is sulfuric acid. And with this, you finish the exercise. I know I did a lot of steps, but remember, this is a review. Okay? This is a review, and I'm explaining like everything. 2 steps process. Any doubts from the exercise 1? Okay, now let's work with part B. I paste the exercise again here to work in the part B. It says, determine the number of grams of solute needed to make each of the following molar solution. Part B says 1 molar solution of nitric acid in 2 kilograms of water. So the first step that I need to do here is remember the formula, okay? Solute plus solvent gives me a solution, okay? So in part B, which one is the solute? Which one is the solute? Is it nitric acid or is it water? HNO3, exactly, Gerald. Okay, so the solid will be nitric acid, HNO3, and the solvent is going to be, therefore, water. I recommend that every time you see a solution that involves water, water will be most likely the solvent. Okay, now, what are the givens in this part B? The
We have
problem,
molar of 1.m.
exactly, they are giving me molar concentration, that is 1.0 or just 1 m. Okay, that is my molar concentration. Now, the problem, remember that we identified the solute and the solvent. We already did, but we need to write it as a given. Now, about the solute, I know it's nitric acid, and about the solvent, I know it's water. And also about the solvent, I know that I have 2 kilograms of water. So, for the solvent, they are giving me information, valuable information, 2 kilograms of water. Okay. Now, what do I need to find? It says determine the number of grams of solute. My solute is nitric acid, so I'm looking for the grams of nitric acid. The grams of solute, which is nitric acid. This is what I'm going to look for. Okay, that is my unknown, and that's what I'm looking for. So the solution process for this problem is quite the same. Okay, so in the first step, we do the isolation. I'm looking for the number of moles of solute because I want to know the grams of solute, so I will focus only in the solute. So the first step will be the same isolation. So you have your equation for molar concentration. You are looking for the solute, okay? Because take a look here, you're looking for the solute. So you will isolate a part of the formula that involves the solute, which in this case is the mole of solute. Isolate moles of solute, and you will have moles of solute equals molar concentration times kilogram of solvent. And now you just replace by the givens number of moles of nitric acid is equal to the molar concentration, which is 1 m, times the kilogram of solvent, that is 2 kilograms. So my number of moles of nitric acid is equal to 1 times 2 gives me 2. 2 moles of nitric acid. And now we're going to the step number 2. Remember, you have number of moles, but the problem asks you about the grams of solute. So here you have to convert from number of moles to grams by using the conversion factor, the molar mass of my solute. So in the step number 2, in the step number 2, you have to do the conversion from moles to grams. So you need the molar mass. The molar mass of your solute, that is HNO3, you can get it as 1 hydrogen, 1 invisible nitrogen, and 3 oxygens. Replaced by using the atomic masses. So you have 1 times 1 gram, you have 1 times 14 grams, and you have 3 times 16 grams. In total, you have 1 gram plus 14 grams plus 48 grams. How much is this? How much is this?
63 grams per mole.
63 grams per mole. Remember, this is the same as having 63 grams over 1 mole. And this is the conversion factor that you actually use. So you say, you do the conversion process, that is 2 moles of nitric acid times, okay, here, where am I going to write the number of grams, up or down?
Up.
63 grams are coming up, and below you write the moles. You cancel moles with moles. How much is this?
126.
126 grams of nitric acid. As you can see, this process is very simple. I really hope you get 10 out of 10 in the quiz. Shayla and Jennifer, I don't know why I don't see your. Okay, guys, you're gonna force me to have a different rule for you. You need to show yourself in front of the camera. If I don't see you, it means that your phone is upside down. You're not in the class. Okay, that will be it for molar concentration, and I want to make one more example for molar concentration for you to see. Now, how do I recognize if I have molar concentration or molar concentration? It is given in the units. Okay? Remember, uppercase M means molar concentration. Lowercase m, and is most likely in cursive, is molar concentration. You need to be careful on that because that is going to define what formula to use. Now here we're talking about a solution that has 2.2 molar. So this means that this exercise is from molarity. Okay, and according to the equation that I gave you for molarity, molarity is equal to number of moles of solute divided by liters of solution. Okay, so for this exercise, this is the equation that we will be using. So I need to focus on this. Okay, I need to focus on the number of moles and in liters of solution. So let's take a look. It says how many moles of sodium hydroxide are contained in 65 milliliters of a 2.2 molar solution of sodium hydroxide in water. So again, first what I do is I write the equation for a solution. The equation is solute plus solvent gives me solution. What is the solute in my problem? What is the solvent in my problem?
H2O. Water.
NaOH is my solute and water is my solvent. Water is a key. If you see water, it's most likely the solvent, okay? Unless it is specified in other way, water will be the solvent, okay? So, what do we need according to the formula? We need the liters of solution, we need the moles of solute, and we need the molar concentration. So these are the givens. They're asking us about the number of moles of NaOH. Remember that NaOH is the solute. So they're asking me to find the number of moles of solute. Okay, this is unknown. In the other hand, they are giving us the volume of the solution. The volume of the solution is here, 65 milliliters of sodium hydroxide in water. Okay, so they are giving me 65 milliliters of solution. So according to the formula, I need my solution to be in liters. Okay, they are giving me milliliters, which means that I need to perform a conversion from milliliters to liters. So I need to convert from milliliters to liters. So you say 65 milliliters times. What is the conversion factor from liters and milliliters? Where am I going to write the liters, up or down?
Up.
So 1 liter comes up, and the conversion factor between liters and milliliters is there are 1,000 milliliters in 1 liter. You cancel milliliters with milliliters, and this gives you 0.065 liters of solution. Now let's solve the problem now. So the solution process will be I need to isolate for the moles of solute, okay? That is my unknown. So I'm going to perform exactly the same kind of isolation. So this one is dividing. I'm gonna move it to the other side to multiply, okay? It is dividing and it goes to multiply. So the number of moles of solute, my solute that is NaOH, is going to be equal to my molar concentration times my liters of solution. Molar concentration that is 2.20 m, and the liters of solution that is 0.065 liters. So how many moles are these? How many moles are those?
0.143.
0.
143.
Okay, and these are moles of sodium hydroxide. And voila, that's it. But if I ask you, for example, if I ask you, instead of moles, I ask you grams, you will have to perform the conversion process from number of moles to grams by using the molar mass. Okay, so it will depend on the problem. If just ask you moles, this is the right answer. If it asks you grams, use the molar mass as a conversion factor. We'll study for Thursday. Thursday we do the quiz. Goodbye.